Okay, so just quickly here, we're going to start modeling a couple of grids in each direction, a couple of structural grids, numbers in the X direction and letters in the Y direction. For simplicity, we're just going to then put a concrete slab around the outside. Here, what we're going to do is just grab each edge and constrain the size of the slab back to the grid so that it's 500 mil off the edge of those grid lines, meaning that if we change the spacing of the grids, the size of the slab will change together with the grid, as you can see here. I'm then going to go and place a couple of columns at the intersections of 2, 3, B and C, either individually or do it a more easier way by selecting all the intersections of a selected number of grid lines. It's important to, take note that, we also need to put slab thickenings around the outside. So we're going to define the size of that thickening, pick the edges of the slab around the outside to put our thickenings in our particular concrete slab. We're also going to place a series of footings underneath the columns themselves. And in one case, we're actually going to change the size to make them bigger than the other one, just to show a bit of contrast and difference in what we're doing. Then finally, to cap it off, we're going to sit down and actually create the slab that's on top of those 4 columns, giving us the capability to be able to visualize something in the space of our model, just for reference. So what I first do is I select the edges and lock them to the face of the concrete columns, and then I go and fillet those edges, making sure to choose our span direction as well, noticing that all the edges are constrained to the size of those columns that are in that view. Okay, so what we're going to do is place some filters. Before we do, you can see there's lots of different types of rebar diameters inside our model. To create the filters so that we can color code them, we come into the filters area, we create a new filter for the diameter we want, come down and select rebar as the filter object type, and then filter by a particular type name which is equal to the type that we're going to filter for. We do this for 2 times, so once for 16, one for 22, obviously not Australian sizes, but the concept is what I'm trying to show here. Again, setting up the filter for that next level for 22. Once we apply these filters, right, we pick OK, we come back into our filters tab and we add the filters and provide our overrides based on what we want them to be. So in this case, yellow with a solid edge, with a solid line, solid coloring, giving us the ability to have the colors, or in cyan, whatever it may be, and repeat that process for the different types of colors that we want to apply to give us that contrast inside that model to make it easier to navigate that model. Okay. So what we want to do is create a transparency filter or a series of transparency filters. So what we do is we create a new filter name for the first transparency setting. We come down and select all the object types that we are going to potentially apply this to. Beams, columns, walls, slabs, whatever the object types you want to do. Then once you've got this set, we're going to choose a filter based on a comment. We're also going to duplicate that and make a secondary one where we've got the same selection made with the same objects, but obviously we're going to have a different comment, with that being T2. And if we go double check that first one, just make the correct selection and make that equal to T. We then go and apply those same filters, to the objects themselves. So we come back in, select all the structural columns, pick OK, add the T into the column comments. Then we go and select the slabs and add the T2 comment or T comment in there as well, right? We come and apply those filters to the list, specifying a transparency for T1 and T2, giving us the ability to then be able to set a real contrast or difference in transparency across your model, as you can see here. So what we're going to do now is we're going to switch to our north direction view and create a quick section. We're going to rotate that section by 90 degrees just to allow us to take a cut through the model. We're going to move it a little bit, shorten the depth of our view, of our section view, then go to the view so we can start placing rebar. Zoom into the column. We go and choose the rebar command, where we're going to go and place a series of straight rebar, just nudging it slightly to the edge, and it will snap right onto the edge, and you'll see what I mean when we edit constraints shortly. When I pick the rebar and edit constraints, pick the vertical direction, you can see it's constrained to the edge of the column. Hence, if I make it minus 300, it's exactly in the middle of that column. If I go in the other direction, you can see it's constrained to the cover down the bottom, right? If I go and select one of these corner items, bars, you can see they're constrained to the edge of the cover because I've used the edge option in the constraints, right? We'll check the other one. You can see it's exactly the same thing, both constrained to the cover by the edge, meaning that if the cover changes or moves, it's going to change with it. I grab those bars, I come in and mirror those bars about the center of the column, and then what happens, just to make sure, I'll go and grab those bars and I'll go and check the constraints, and you can see that the constraints have mirrored along with the mirroring of that actual bar. I then come and make a selection of all my rebar, choose to copy from the center of one column to the other column because we want to obviously do things a lot easier, a lot faster. We will then switch back to our concrete detailing view where we can see our rebars in lines. We can obviously change this by setting the solid and obscured per bar, select all the bars, and we can change them as we go. However, a way to do this faster is to come into your Dynamo player, load some scripts into Dynamo, and then execute those scripts, and they will change in this case, change all the rebar in my model to be set the same way. And you can see I've got two scripts, so I can toggle between those states quite quickly. This is obviously quite a good enhancement. If we go back to the slab view on level 2 and go and place some area reinforcement, we select the slab and start selecting the lines around the outside of the actual slab for the extents of the view, making sure to pick the rebar direction and lock those elements all the way around as well. Once you've finished, you hit the green tick and you end up with a series of bars in each direction. And you can see this, you can see the system line in the middle and the rebar as lines elsewhere, right? Down the left, you can see there's loads of options for different bar sizes, spacings and whatnot that you can adjust and manipulate as you go through. You choose a different bar size in the other direction, whatever. You can see those changes appearing. Of course, we want to see them solid, so we come back into our Dynamo player, run our script, execute our script, and then we end up with the bars, or we should end up with the bars in the display that we're preferring to see them, right? In this case, I actually turned them the opposite, so you can see I just manually adjusted it there, and then off we go. Okay, so what we're going to do is look at the hooks. So we select the rebars that are set in this column here, but before we do, we'll just quickly come and change some of these bars to try and make it a bit visually a bit more easier to see. Change this to a 32 and change that one to a 22. hit the apply button after we make some more changes. That's it, one more, and yep, then we hit apply. Right, you can see the colors change quite quickly as well because of our filters. We select our rebars themselves, and we go and change and put in a 90-degree hook. Hit apply. You can see the hooks come in the wrong direction, so we're going to rotate that 180 degrees, and that should then flip the hook around the other way. Fantastic. This is a very easy way to place a hook. Obviously, I can model it in an L shape as well, but modeling a straight bar is easier than modeling a L-shaped bar or sketching a bar. Obviously we can grab the other bar that's individual in that corner, apply the same hook, and then toy around with the rotation if we so want to manipulate the direction that you want the hook to go. Whether it's 90 degrees in one way, 90 degrees in the other, it doesn't matter. You sort of get the idea of what I'm trying to show you here anyway, right? We can also obviously turn the thing off. Now you can see here in this particular case, the hook length is grayed out because it's coming from the family itself, right? So, if you come and see the type and come and look at the hook lengths dialog box, you can see there's a bunch of formulas here telling you what the hook should be, or the hook length should be. But if we want to override it, we tick this particular box here, and that field will allow me to now override it and put the exact hook length in that I want for that rebar. Right. So what we're going to do now is going to have a look at placing rebar next to other rebar. So again, we're going to come in, place some single rebar, just place it close within proximity of the other rebar. Then we're going to edit the constraints of this rebar. This is a really cool part because you can constrain one rebar to the next one and make it the information or the constraint bidirectional, that if one element moves, the other element will move with it. You can see it here. If we edit the constraint of the large bar and adjust the size to be different, you can see the little bar or the smaller bar moves with that rebar overall, which is super cool. We come back to our 3D view, we orbit around, have a look. You can see the rebar's there. You can probably only just see it. If we orbit around, you can sort of see that magenta line in the corner there. Come back to our Dynamo player, run our script to get our view exactly the way we want it. Then we start manipulating the constraints of the yellow bars. Now with these bars, I can manipulate the constraint on the end of the bar as well. So the end of the bar in this case, I'm constraining the end of it to be 50 mil above the top surface of that footing to keep it just inside that column. And this is because I want the bars to stop inside the column, and the purple bars, which are going to be my starter bars, I want them to be 1200 inside the column from that top surface. So you can see I grab the end of that bar, adjust the constraint to the top of the footing, and I repeat it twice to give it that 1200 mil offset from the top face of my footing, each time being able to manipulate the bar the way I need it to. I need to obviously come and select the bars and now place that hook to give me the starter bar that I need. It's obviously got the wrong rotation, so we keep toggling that rotation until we get the rotation exactly how it is that we want, to then get it what we need. We obviously need to change the length of that hook as well to give it a bit more embedment. So we select that hook, tick the box to override the value of the hook, make it 500, and off we go, and our bar is set correctly. You can see with single bar placement, there's a lot more manipulation to be done. So what would happen if I was to place multiple rebar? Let's delete this rebar and have a look at that situation now. So we come back to our north view and go straight to our section view, and we go to place rebar inside this concrete column. This time when we choose the rebar option, we don't leave it as single, we change it to a fixed number and change it to the number that we want. And you can see it automatically places the number of rebar in the available space, giving you the rebar, in that direction, the quantity that you need, right? This is a set of rebar, and again, when you go near an edge, it hovers and sort of gets sticky to that edge. If we look at this rebar constraints, and look at the properties of the constraints, you can see the constraints all the way around on each side, the two vertical constraints and the horizontal constraint is all constrained back to the cover steel, giving us the same desired effect, but it's one single object. We repeat that process for the bottom half. Obviously, we could have mirrored that as well, but in this case, we just want to talk about the multi-rebar. Right, finish that and then switch back to our 3D view. Once in our 3D view, we sit down and we obviously need to change the display of our rebar back to being solid because we've placed some brand new rebar here. Again, we run our Dynamo player to get the automation. This time around, when I select the bar set and edit the constraint and select the surface and tell it to be 50 mil above that surface, it changes all three bars in one go, seeing that you can actually place bars a lot more efficiently rather than having to place one bar at a single time. In recap of what we did today, we talked a lot about manipulating hooks, display of rebar, whether it be 3D or unobscure, in particular the Dynamo player. Investigate it more. If you haven't looked at it already, this is something that can really benefit your business because it can save you a lot of time. The other thing that we looked at was the ability to run or to manipulate filters to change the display of our rebar and manipulate the transparency of our objects, hence giving us a better experience. Thanks.